what does this look like in action then? So first of all, integration by substitution is going to be this opposite or undoing the chain rule essentially. So it's not going to quite look like the chain rule, but it is theoretically the undoing of the chain rule. So to apply this, we really need to see it in action and see how we set it up. So here's our integral that we couldn't integrate before. We have this 2x over x squared plus 1. It cannot be integrated with power rule because there is no way we can isolate a power on any of the parts. Okay, especially when we have this binomial denominator, we really can't simplify this. So how does it work? Well, the key to integration by substitution, okay, I've written in purple here. What we need to do is we need to choose an inside function u such that its derivative will eliminate the leftover term in the expression. So what do I mean by that? Well, let's say we choose the green x squared plus 1 as my embedded function u. The derivative of u, when I differentiate u, I get du by dx. What I'll end up with is just 2x. And what ends up happening is I want to isolate the du, so I'm just going to algebraically move that dx to the other side, and I end up with this expression right here. I generate a du expression. And what ends up happening then is that the leftover outside term, in this case the 2x dx that wasn't part of the substitution, can be replaced with du. So why do we want that to happen? Well, if I do that, notice what the expression that's left over here. I end up with this expression. I end up with the du replacing the x dx. I replace the denominator with u, and so I end up with an expression 1 over u, and I'm using a du to integrate it. Well, the u and du are matching variables, right? Just like as if it were an x. So if the variables match, I can just anti-differentiate this, knowing that this is a standard integral. Well, 1 over u turns into log of u plus c. Now, we don't want our integral to be in terms of u. We actually want this in terms of x. So what we're going to then do is we just replace the u with an x squared plus 1. And by doing that, we've now brought it back in terms of x, and there is our integral. So let's see what happens here, because this is hard to see what happened, but it's going to be a little bit easier to see what happened when we differentiate. So we're just going to check this. So we're going to check this by differentiating this. So I'm just going to differentiate log x squared plus 1 plus c. The derivative of log is going to be 1 over x squared plus 1. I'm just going to maybe do this here. I'm going to go 1 over the embedded function, x squared plus 1. And then I'm going to attach onto that the chain, which is the derivative to x. And then plus c differentiates to 0. So notice that we actually generate the original integral that we started with up here. So it does work. So if our derivative generates original integral, then that must be the antiderivative function.